Hello everyone. I am Harith Reddy, working as assistant professor in St. Peter's Engineering College in the department of CSE. Today let's see about binary search. Binary search is a technique which follows a divide and conquer method. In divide and conquer method, a complex problem is divided into subproblems and each subproblem is solved independently, and the solution of each subproblem is merged together to form a solution to a complex problem. Now, if you want to perform a binary search, first of all we need to take an array. So this is an array. Every array is given a name, and if we want to perform a binary search, all the elements in an array should be in a sorted order. For example, let's take these elements inside an array: 11, 12, 13, 14 and 15. These are the elements of an array. A is the name of the array, and the index values of arrays are represented from 0, 1, 2, 3 and 4. So in this array we have 5 elements. That 5 elements are denoted by n is equals to 5, and initially the concept of this is based on calculating the mid value. Always start value will point out to the index value 0. So this is a start value. Start is a value which always points out to the index value 0, and end value, this is the end value. End value will always point out to the highest index value. So end will be equals to n minus 1. For example, if we are having 6 elements, the array index is represented from 0 to 5, and end value will be equals to 5 here. Now we have to calculate the mid value. We have to calculate the mid value. So mid value is nothing but start plus end by 2. Start plus end by 2. This is a formula to calculate the mid value. Okay, for example, let me assume that I would like to find an element value 14. So whatever the element I would like to find, that element value is stored in a variable called key. Now if I want to find the element value 14, that 14 can be either equals to mid value, or greater than mid value, or less than mid value. The three conditions can be true. Three conditions can be true. So what is the first condition? Whatever the key value you want to search, that key value can be equals to your mid value. Or second, what is the second rule? Whatever the key value you want to search, that key value can be greater than your mid value. And what is the third value? What is the third possibility? Whatever the key value you can find, that can be less than or equals to your mid value. For example, I would like to search 14 now. I would like to search 14. Now I am going to calculate the mid value now. Mid value is 0 plus 4 by 2, which is 2. Okay, now this is my mid value. I would like to search 14 now. 14 is greater than a of mid, so definitely I would like to search the element onto the right side of this mid value. So here the searching it reduces much time complexity. Here directly we can go to the right side of mid and we can find out the 14 value. Okay, now now I'll take an array for your example now. So again I am taking an array. Earlier array itself I am taking. Now in that array I am going to store 5 elements. Let that elements are 11, 12, 13, 14 and 15. So this array is having the index value 0, 1, 2, 3 and 4. So these are the index value. Now I would like to search the element called 14 here. So this is what the element I want to search. This element can be present in an array or it cannot be present in an array, as I said earlier. So three possible conditions are there. So first one is your key value can be equals to your a of mid value. This is first condition. Now key value can be greater than a of mid. This can be your second condition, and key value can be less than or equals to a of mid. This can be your third condition. This is first, second and third condition. Okay, now I would like to search a key value 14 now. So first what I am going to do means I am going to calculate the mid value. As I said you, this is my starting index value and this is my ending index value. So this is my start value, this is my end value. Immediately I would like to calculate the mid value. Mid value is nothing but 0 plus 4 by 2, so which is equals to 2. So this is my mid value now. So I would like to check whether my key value is less than mid or greater than mid. So key value, and I like to calculate my a of mid value. So my key value, what I want to search is 14, and my a of mid value, a of my mid value is 2. So 14, and what is a of 2 value? 13. 14 is greater than 13. So what we have to do in the next step, we have to move this pointer next to this mid value. That means whatever the element we want to search, that element will be existing onto the right side of this mid value. Okay, now this is 11, 12, 13, 14 and 15. So earlier start was at this position. Now if this condition is satisfied, if key value is greater than a of mid, if key value is greater than a of mid, if this condition is satisfied, so start pointer should be incremented to mid plus 1. This is the logic here. Now so this is my mid value. Now this is 0, 1, 2, 3 and 4. These are index values. Earlier my started at 0 position. Now as per formula I should move that start value to mid plus 1. Now this is my start value, this is my end value. This is my start, this is my end. Again I need to calculate the mid value again. Now mid value will be start plus end by 2. So start value is 3 plus 4 by 2, which is equals to 3.5. Take the ceiling value, which is 3. So this is my mid value. Now this is my mid value start, and mid is pointing out at the same location now. So I would again, after calculating the mid value, what I need to do is that I should check what element I need to find. Now I need to find my key element and I need to check my a of mid element. So here a key value is 14 and a of mid value is 3. 14 and a of 3 is what? 14. So my mid value is equals to my key value. So I can say that the element is found. Okay. So this is about the binary search. So this is about the binary search value. Now I would like to give you another example to search an other element. Now I am going to take the same array. Now I need to find the element number 15 now. So array A is there. So 11, 12, 13, 14 and 15. So this is an array, same example I have taken. So these are my index values 0, 1, 2, 3 and 4. So this is the starting pointer, this is the ending pointer. Now I need to find out the key value called 15. So if I want to find out 15, I should find out my mid value. So based on the mid value, I can decide whether that element is existing to the right side of the mid element or the left side of the mid element. Now so mid value I am going to calculate. Mid value is 0 plus 4 by 2. Now mid value is 2. So it is very clear that my mid value is at 11, 12, 13, 14 and 15. Sir, this is my mid value. Okay, so this is my starting index value, this is my ending index value, this is okay. Now whatever the element I want to find, I want to find 15. Now this 15 is greater than a of mid value. 15 is greater than a of mid value. That means 15 will exist on the right side of the mid value. Okay, now immediately if this condition is satisfied, so if your key element is greater than a of mid, so we have to increment the start pointer. We have to increment start pointer. So start is equals to mid plus 1. For example, if you want to search 12, so your end pointer should be decremented to mid minus 1. Now you want to search 15. 15 is greater than a of mid, so start value should be equals to mid plus 1. Now immediately in the next step what happens? So again here 11, 12, 13, 14 and 15. So your start value will be mid plus 1. This is 0, 1, 2, 3 and 4. So this is my start pointer value, this is my end value. Again I should calculate my mid value now. So mid value calculation, the formula is starting plus ending value by 2. That means 3 plus 4 by 2. Okay, so 3 plus 4 by 2 is something around 3.5. We should only consider this 3. So that means your mid value is M stands for mid value here. Your mid value is pointing out to third index now. Now what is the key value that you want to find? 15 is the key value that you want to find, and your a of mid value is 14. So your 15 is greater than 14. So what we have to do, again this condition is applicable. Start value is equals to mid value plus 1. Now initially start value is equals to if this condition is satisfied, so here I have written the formula. If the key element value whatever you want to find is greater than a of mid, so start equals to mid plus 1. So your mid value is already 3, you got it here. So mid plus 1 will be start value will become what? 4, which is mid plus 1. Now in the next step 11, 12, 13, 14 and 15. So this is the index value 0, 1, 2, 3 and 4. 0, 1, 2, 3 and 4. So this is your mid value now. This is your end value. Now start value is equals to 4. This is your start value. After incrementing the start value, again you need to calculate the mid value now. So mid value, again I need to calculate whenever I am incrementing the start pointer or decrementing the end pointer. Afterwards I need to calculate mid value now. Mid value is equals to 4 plus 4 by 2. 4 plus 4 by 2. So that means I got my mid value as what? 4. Now starting pointer, ending pointer and middle pointer is all pointing out to the index value 4 now. Now I need to check. Now key value I want to find is equals to a of mid now. Now key value what I want to search is 15. 15 is equals to a of 4. A of, this is an array A, fourth element is what? A of 4 is 15. 15 equals to 15. The key element is found. This is about binary search. Now I would like to write the algorithm for a binary search. I like to write an algorithm for a binary search. So algorithm can be written as algorithm followed by algorithm name. Algorithm name is binary search. So if you want to perform this binary search, binary searching, so you require an array. So that array is represented by letter A, and inside that array you have to store the elements. Let the number of elements are represented by using n, and you require a key value. What value you want to search, that value is called as key value. Just now we have seen that. So initially we have seen, so starting index value, whenever I have started the searching technique, initially this condition should be satisfied. Starting value should be equals to 0 and ending value should be equals to n minus 1. Ending value will be equals to n minus 1, and now I should calculate the mid value. As we have seen, so that mid value can be calculated when this condition is satisfied, while starting value is less than or equals to end. If this condition is satisfied, only then we can perform searching, or else we cannot perform searching technique. So starting should be always less than end value, then only we can perform searching technique. When this condition is satisfied, if the start pointer is less than end pointer, then immediately we need to calculate the mid value. So I have said you the formula for mid value. Mid value should be start plus end by 2. Start plus end by 2. This is the formula for calculating the mid value. After calculating the mid value, as I have said you, 3 possible conditions can be possible. The first possible condition is that if a of mid is equals to if your key value, if key value is equals to a of mid, so whatever the value you want to find is equals to a of mid, you can directly write that element is found. Instead of writing element is found, I am writing the mid value here. This is the first condition. So whenever you are searching a key value, you are calculating the mid value. If the key value is equals to a of mid value, you can directly write the element is returned. Now second possible condition, else if your key value can be greater than a of mid. Whatever you want to search, if that element is existing onto the right side of the mid value, just now we have seen that example. So starting pointer should be incremented by 1. Start is equals to mid value plus 1. This is the second condition. So third condition is nothing but else whatever the element you want to search, that element can be less than a of mid. If this condition is satisfied, so we are going to decrement the end pointer. End pointer is equals to mid minus 1. Okay. Now if in the case start pointer is greater than end pointer, if this condition is failed, until and unless this condition is true, we are going to perform the searching technique. Once this condition is failed, so the control comes here. While start value is greater than end, we can write printf or element not found. Okay, now I'll take an example here. Now one small example. Now I would like to take an array again. Let A is the name of the array. Inside that array I am going to take the 3 elements 11, 12 and 13. 11, 12 and 13. Now these are my index values 0, 1 and 2. Okay, initially start pointer is pointing out at here and end pointer is pointing out at this location. So if n is equals to 3 elements are there, so n minus 1 will be equals to 2. Starting is at 0, ending is at 2. Now start value is less than end value 0. This is the start value and 2 is the end value. The condition is satisfied. Now the control will pass inside the loop body. Now mid is equals to start plus end by 2. So mid is equals to 0 plus 2 by 2. Mid is equals to 1. Mid is equals to 1. Assume that the key element I want to search is 12. Assume that key element I want to search is 12. Now key value is equals to a of mid. My key value is 12. 12 equal to a of mid. A of mid value is what? 1. 12 equals to a of 1 is what? 12. The condition is satisfied and we can write that the element is found. Return mid. That means we are going to write down the value what is there inside that mid value. Okay. Now assume that I would like to search the element 13 now. I would like to search the element 13. Okay, these are 11, 12 and 13. 11, 12 and 13. These are my index values. Now I would like to search. Assume that my key element is 13. Key element is 13. Now this is the start pointer we have seen. This is the end pointer. So mid value will be equals to what? 0 plus 2 by 2. Mid value is equals to 1. This is my mid value. This is my mid value. Now 13, whatever I want to search, that is 13. 13 is greater than a of mid. 13 is greater than a of mid. So 13 is greater than a of 1. It is true. If key value is greater than a of mid, so start value is equals to mid plus 1. Start value is equals to mid plus 1. So mid value is 1, mid plus 1 is 2. Start value will be equals to 2. End value will be equals to 2. Obviously mid value will be also equals to what? 2. Now I'm writing here. So this is array A, this is 11, this is 12, this is 13. Now start, this is end and this is mid. All these are pointing out to the same index location, which is 3. Now the element I want to search, what is the element I want to search? 13. 13 I want to search is equals to a of mid. I can say that my element is found. Okay, and the last case, for example, what if we want to search the element 11? The element 11 value is less than mid value. Now I will be explaining that concept for 1 minute. Now assume that this is index value, this is index value 0, this is 1, this is 2. Now whatever we want to find, that element is existing to the left side of the mid value. Okay, now starting value is 0, ending value is 2. Starting value is 0 and ending value is 2. My key value is 11. Now I would like to calculate the mid value. Mid value will be equals to 1. 0 plus 2 by 2 is mid value is equals to 1. If we want, I'll write the formula now. 0 plus 2 by 2 equals to 1. Now my mid value is at index value 1, which is 12. This is 11, this is 13. Now this is start pointer, this is end pointer, this is mid pointer. Now whatever the key value you want to search, that key value will be less than or equals to mid value. So this third condition will get satisfied. If key value is less than mid value, end value will be equals to mid minus 1. Okay, end value will be equals to mid minus 1. Now we are going to remove this end value. Now end value will be pointing out here. Whenever we are decrementing either start or end pointer, immediately we need to calculate mid value. Now after calculating the mid value, what I am going to get? So your start pointer and end pointer is pointing out to 0. 0 plus 0 by 2, which is equals to 0. Now this is also your mid pointer. Now mid pointer, start pointer and end pointer is pointing out to the same index value. Now key value is equals to key value is equals to a of mid. This condition is satisfied. So whenever this condition is satisfied, we can say that the element is found. Key value is 11, a of mid is also equals to 11. We can say that the element is found. This is all about binary search. Thank you.